Thank you everybody for coming out this afternoon. Here we have, very proud to present Rob Miller. He's a professor at MIT. He was actually my thesis advisor at MIT. And so today we're going to present some of the work that we did together and some of the new stuff that's going on in Rob's lab. So I'll let Rob start things off.
Thanks, Michael. I should acknowledge also the help of lots of students that went into this work. Not just Michael, this was his master's thesis, actually award-winning master's thesis at MIT, but also Greg Little, who has contributed some of the most recent stuff, and a number of undergraduates, Eric Lieberman, Marcus Ojeda, Matt Weber, Philip Rao, Tom Wilson, and Darius Hupp. So here's the problem that we're interested in. The web, as we all know, is now an application platform. Websites are no longer just static pages that deliver information to us. Instead, they're rich applications where we spend a lot of our time. And as we spend more time with these applications, we want to be able to customize them for our own needs. For example, one thing that I'd really like to do with my bank is set a bookmark on my latest bank statement. Bank doesn't let me do that. Instead, I have to log in, I have to go find the statements link, click on that, go find the beginning, the first statement on that list, click on that, and that finally gets me to my latest statement. So I'd like to be able to automate that and get a bookmark that will deliver me to my current statement. Another example is whenever I download open source software, it displays a bunch of mirrors and has me click on the closest one. I'd like to automate that so that it finds the nearest one for me automatically. Another kind of automation, another kind of change that I might want to make to a web application is to transform its appearance. So if its color scheme is ugly, if it's unreadable, I'd like to be able to change that. If it splits up results into multiple pages, making it hard for me to scroll through them or search through them with my browser find feature, I'd like to be able to glue them back together. So add an option to that table of contents there that will let me glue all those pages together. Or I might want to simplify the web app so that it removes features that I don't actually use and don't care about. The final kind of customization I might want to make is to take two web apps and mash them up, make them work together. So a good example of this that I care about is, when I search Amazon for a book, it'll offer me a choice of buying it new, or buying it used, or buying it from an auction. But it's not going to tell me whether it's available in my local library. And I probably shouldn't hold my breath for Amazon to implement that feature for me, right? But it's something I can do myself. I can get the information about the book out of that Amazon page and go over and submit it to my library catalog and find out whether it's in the catalog, and then bring that link back and inject it back into the Amazon page, so it's as if Amazon had implemented that feature for me. Another example is when I went house hunting recently, and I really wanted to add to these real estate sites a feature that would tell me how long my commute would be if I bought this house. Right? The good thing is that web applications are inherently accessible to this kind of change, right? They have built-in hooks that let us play with them. Their connection to a backend uses HTTP, which we can simulate. It replies with sort of machine-readable XML, ideally, but sometimes just HTML, but at least you can parse it and get data out of it. And what's displayed on your screen as a user is something that you can go into and change. You can change the HTML, you can change the CSS. Desktop applications, the world we were coming from, the desktop didn't have these hooks unless the application developer intentionally provided them. Right? Whereas with the web apps, they're already there automatically. So it's possible for end users to change these applications, and proof of it is in the existence of systems like GreaseMonkey, or user JavaScript in Opera, which lets you inject a chunk of JavaScript into a page in order to change the way it behaves or the way it looks. But it's not easy, and this is one of the things that we're interested in tackling. In particular, there are two barriers to doing these kinds of customizations that we've identified. The first one is that when you look under the hood of a web app, even an incredibly simple one like the Google homepage, it's more complicated than the user interface. Right? So Google has a very simple and clean user interface, but when you actually look down at its HTML, there's a lot more complexity there for you to understand. So if you have to customize it down at this level, that's a real complexity barrier that's going to inhibit you from doing some kinds of automation that you might want to do. The second problem is that you have to know how to program. You have to learn a programming language and understand the syntax and the details of using that programming language. So here, this is actually a chunk of of a grease monkey script, and all it actually does is find the URLs on the page and turn them into hyperlinks. Right? So it's a very simple thing to do, but it requires some very complicated code to actually do it. So we want to tackle both of these complexity barriers. And our approach for the first part is to avoid digging down to the HTML code. So we want to try to automate and customize web applications entirely at the user interface level without having to look under the covers. And so that's going to be the bulk of our presentation today. That's what the Chickenfoot system is about. The second problem, which we've only just started to look at, so we don't have a kind of complete system there, only some first prototypes, we want to look at how we can avoid having to learn syntax by just using keywords to describe what it is that you want to do. And you'll see some examples of that later in the talk. So here's the system that we built that embodies these ideas. It's called Chickenfoot. It's a JavaScript development environment. That is, at root, it's a JavaScript programming environment. But it's geared towards end-user programmers as well as traditional web hackers. And the key goal here is that whether you're an end-user programmer or a web hacker, you shouldn't have to look at the HTML source of the pages that you're working with in order to customize and change them. It's a Firefox extension. It's a little sidebar here, and it's available for download. The URL's here. You'll also see at the end of the talk. So that's a quick introduction. What I'm going to do now is hand over to Michael, who's going to give you a quick demo of Chickenfoot, and then the rest of the talk we're going to first kind of focus on end users and on the novel approaches that we've come up with for reducing complexity for them, and then Michael's going to talk about how you might use Chickenfoot even if you're a hacker, even if you're a web developer, and take advantage of some of its unique features. So let me hand it over to Michael.
Thank you, Rob. So let's move over into Firefox. So let me start out. So this is the Chickenfoot sidebar that we saw a little screenshot of. So at the top here we just have a regular editor for JavaScript, and you can write JavaScript just like you would be able to write in a web page. So I could change the background color, right? Run the script, change the color. Nothing too fancy there. But we're more interested in end user programming and things that we can do from this sidebar. So we're going to start with a little example about how you could customize this page. So say you wanted to customize image search. That is really easy to do a search for icons. And by icons I mean small GIF images. So normally the first thing that you would do if you were going to do such a thing is you'd have to go to the advanced image search. So there's a link for advanced image search over there. So in Chickenfoot I can just say click advanced image search. And I can run this, and that will take me to the image search page, as I'd expect. The next thing I want to do is, let's say we want to do a search for calendar icons. So we need to get the word calendar into this box, because this is the search box. So we need to find need a way to identify this text box in the page. So in Chickenfoot we actually have a patterns pane, where you can choose different types of patterns, such as button, link, list box, and see what Chickenfoot matches. So in this case, if we do a search for a text box, we'll see that Chickenfoot matches 5 text boxes, but we need to match the first one. So Chickenfoot actually can look for keywords in the page and tries to associate them with elements. So in this case, if we went with the all of the words text box, I try to match that, then now we see that I uniquely matched this box. So I can use this in my Chickenfoot script up here, and I can say enter all of the words text box, and I will do a search for calendar, or enter something. So when I run that, the word calendar appears in the box. So similarly, like I said, we want to search for small GIF images. So here we want to choose small, and here we want to choose GIF files. So Chickenfoot has a pick command that can pick items from a drop-down. So I can say pick small, pick GIF, and when I run that, it chooses those from the drop-down as we would expect. And then for the last step, we need to click the Google search button. So I can just say click search button. And I run that, and that will take us to the results page as we like. So this is neat, because now I've just been able to automate this entire process without knowing anything about the underlying HTML, what the form names are, if it's even a form, or anything like that. But the problem is that this is just hard-coded to do a search for calendar icons, so that's not too interesting. The other problem is that right now I need to type stuff in to the Chickenfoot sidebar to do my search. But the Google image search page already has a box for this, right? There's a box for me to input my search query, and there's a button for me to click on to search for images. So instead, I'd rather take advantage of that and just add my own button. So in Chickenfoot, we can write insert after the search button. Then we'll add a new button. So in Chickenfoot has a button constructor, and the first argument it takes is a label for the button. And the second argument is a callback function. So say, but the contents of that function is going to be the Chickenfoot script that we just wrote. Where that one? After that. All right. Friend matching is not something we've implemented yet in Chickenfoot, unfortunately. Oh yeah, thank you. I need to undo click. Right now, this is actually still hard-coded to do a calendar search, so I really want to be able to get the value out of that text box. So I could just say text equals line text box, and then I can get the value out. And then I'll replace calendar here with that text. So if I run that, now if I run this script, now we'll do search for something else, search for pencil icons, and I click the icon search button. It'll go through page by page and fill out the things that I told it to do. So one of the also interesting tricks here that Chickenfoot is doing, actually, you'll notice, is that I tell it to click and then enter and then pick, and it waits for the page to load. And this was actually a tricky part of Chickenfoot, to synchronize the commands to realize that when a page is loading, it should wait until that page is finished loading and to operate on the next page that it gets. So right now we have like a pretty nice script, but now as you see, I've come back to the image search homepage and my button is gone. So this isn't quite as useful as I'd like. So what we really want to do is make sure that button comes up whenever I go to the image search page. So there's an idea in Chickenfoot called triggers, where you can set a URL or a pattern of URLs to trigger the script that you've written. So in this triggers box, I can click this button to add a trigger, I'll give it a name, and I'll give it a URL. So I'll say whenever I go to images.google.com. And so now this trigger is installed. And so now even if the Chickenfoot sidebar is closed, whenever I go to this page, the icon search button will be there. So now end to end, you can customize a website, right, without looking at the underlying HTML, and just have it always be part of the page, without, so it's more seamlessly integrated into your browsing habits. So that's an example of how an end user can use Chickenfoot. So just to show you some of the other things that we've built with it. So we have one that matches SAT words in the page. So this one just goes through and we took a list of SAT words from the site. So when we run this on pages like New York Times, it highlights words that it considers SAT words, which may be a little low level right now. And then when you mouse over them, you can get their definition. So if you're some high school kid and you're studying for the SATs, you might want to run this on all the pages that you hit. Another one is Barnes & Noble, runs on Barnes & Noble page. So this is something that Rob described, where if we'd like to know if this book is available in our local library, so we actually have a script. So when I run this, so if you pay attention right there, when I run this script, it actually goes to the MIT library site, looks up the book, and then as you can see, inserts a link into the page that would take me to the pages listing in the MIT library. So there's different ways that you can pull information from different sites together. And so that's a brief introduction to Chickenfoot. And I'm going to give you back to Rob so he can tell you how it works.
Okay, I hope that gave you a sense for what kinds of things are possible with Chickenfoot. At the heart, Chickenfoot's basically built on top of JavaScript. So anything you could do in JavaScript, you could have typed over in that edit box there. But we've added a few commands on top, implemented a few commands on top to make common kinds of web automation easier. For example, you can easily go to pages, you can interact with forms, you can do searches on pages, you can insert, remove, and replace stuff. But all of these kinds of commands are straightforward. What's really novel here is the kinds of parameters that we're passing to these commands. In particular, the way that we are describing the parts of the page that you actually want to interact with. And what we use for that are what we call keyword commands. And the basic principle here is to use a couple of keywords visible from the page along with a type of a component that you want to retrieve as a description for the component that you want to interact with. For example, you might say feeling lucky button in order to identify the button labeled I'm feeling lucky, or depart text box in order to identify this text box. And we have a number of components, not just these kind of form components, but also images and tables and rows and things like that. And in many cases, the component type doesn't have to be included in the pattern because it can simply be inferred from the command that you're using. So if you're using click and you don't put a component type at the end of your pattern, the system's just going to assume that you want to find something that's clickable. How does this actually work? So inputs are a keyword pattern and the web page that you're actually applying it to, and the matching algorithm produces a ranked list of components with associated scores. And the first step of the process is to take your keywords and search through all the labels on the page for labels that match the keywords. And those labels include actual text nodes that are visible on the page, labels on buttons, labels inside drop-downs, alt attributes on images. And of course, this matching it's tolerant of word ordering and punctuation and capitalization and things like that. Once we have a set of matching labels, we want to find the components of the type that the user has specified that are associated with those labels. And if we're talking about buttons, then the association is pretty easy because the label's directly on the button. But if we're talking about a text box, then we actually have to do kind of a geometric relationship to compare the bounding box of the label that we found with the bounding boxes of all the text boxes on the page in order to determine which text box is most likely to be the one that's being captioned by this label that we found. And then finally, we rank the components according to not just the quality of matching between the keywords and the label, but also the quality of match between the label and its corresponding component. And that produces our ranked list, and we use the top one on the list. So that's a whirlwind tour of what sort of the first problem we were concerned with. How do we automate websites without looking under the covers? The second problem, which is something we're just getting started on now, is what do you do if you don't even know the language, right? So the hope is that Chickenfoot is more readable than the alternative, which I showed at the very beginning. But it's not necessarily more writable because you have to know the exact names of the commands. Is it called click or is it called push, right? I have to know which things need to be quoted and which things don't. I have to know the order of arguments, right? All these things that we take for granted as programmers, but are actually a serious obstacle for end users. So our crazy idea there is to generalize this notion of keyword patterns, which we were using very effectively to identify components, to the entire command. Let's just throw in some more keywords to represent what you want to do to the component, right? So where in Chickenfoot you would have to say things like go google.com with a very rigid JavaScript syntax, the idea with keyword commands is you can write something that feels much more natural. And I should emphasize, this is not natural language programming we're reaching for. We don't have an English grammar over here that is expecting you to write grammatically correct English sentences. That would just be another form of syntax that you would have to learn. What we're looking for instead is to identify that there's keyword in here, go, that tells you that you want to find a URL in there that you want to jump to. The other advantage of not using strict natural language is that if you are an expert, a novice programmer might actually write something like this, because this is the way they might speak it to another human being. But an expert with this system might try to be much more concise because they're already aware of capabilities of the system and how it's likely to interpret what they say. So they might actually omit a lot of stuff, and it would still be interpreted correctly. So how do we actually do this? Very similar to the way we did it with keyword patterns. Split up that command into keywords and search for the keywords in the context that we're dealing with, where the context now includes not just the web page and the visible keywords on the web page that you're working with, but also the whole space of commands that are available in the Chickenfoot system. And then we generate a ranked list of possible interpretations. And we actually use punctuation and ordering to affect the ranking. So if you actually quote something, that's going to boost its probability to be interpreted as a string rather than anything else. So that's one way that the user can control the interpretation process. And then we use the highest ranked interpretation. So let me give you a quick demo of our prototype in that area. This is not yet integrated into Chickenfoot because it's still very new. This box you see up here is basically a keyword command line. So I'm going to type a single keyword command into here, and the system is going to execute it on this page. So what I'm asking you to imagine is moving this box down into the Chickenfoot editor and allowing you to write a whole script of these kinds of commands. Okay? So the first thing I'll do is just something verbose. I don't know if you can see this, but what I'm typing is click on advanced image search link. The system interpreted that, and it was probably too quick to see, but I'll do it again. You got a little feedback about what it was doing, a little green flash here to show you that that's the component it was operating on. It also gave some feedback up here, a stylized English form of how it interpreted your utterance. And in fact, this stylized version is also a keyword command. I could type this. In fact, I pretty much did type that in and get it to do the same thing. I could automate this form by saying something like enter calendar into all the words text box, which again is a verbose way of saying it, but a much more concise way might be to say I want the all words text box to be equal to pencil, for example. So we get a lot of power from just using keywords and ignoring the rest of the syntax. And let's see, I'll also just do the rest of this example. Choose small size and use GIF files, and then go ahead and do a Google search. And so without actually knowing the language, I was able to automate same thing that Michael did, basically using JavaScript. Let me give one more example here. We'll jump over to Yahoo and drill into Yahoo Local. And let's suppose what I want to do, try to enlarge this a little bit, is search for restaurants. Expecting that it's going to fill in this box here. The system actually makes a mistake because this tiny little box up in the corner is also labeled search the web, right? So this is heuristic search. It's ambiguous. There may be mistakes made, and in fact, if this weren't a prototype, we would have done a better job of identifying this ambiguity and presenting it to the user to allow the user to disambiguate, to choose which one they wanted. But in the absence of that, I can still disambiguate by making it, for instance, a little more verbose. So if I say search for in quotes, then that's going to much more precisely match the caption of the thing that I wanted. Right? So if that gives you a flavor of what kinds of things are possible with keyword commands. One question here is this natural? Would it be better? Yeah, question.
I just have a question about your command line back there. Can it interact with Chickenfoot components? For example, back on the image search page, you made a search for icons. Could you have also told it to press that button?
Yes.
Now that Chickenfoot has inserted that button into the page.
Well, let me try that. So the answer is yes. Yeah, because they're all part of the DOM, and it's basically searching the DOM every time you issue the command. So, good question. So, is this natural? I mean, is this the right direction that we should be going with? Yeah.
Can you come and go back to the Yahoo page?
Sure. You're gonna ask me to do something that ain't gonna work. Right?
Here, there are two search buttons that are exactly the same.
Yes. So that is harder to disambiguate. One thing that we don't have implemented yet, but that would help here, is more context, more temporal context about what you've been interacting with. Yeah. So that once you fill something into this box here, and then you say search, it will prefer search buttons that are associated with that box.
It's a part of the same form, most likely.
Yeah, so the relationship is very close. We can figure it out from the DOM, and wouldn't be any problem. Another way to deal with it, which I don't like showing because it feels really, it's not very robust to changes in the page, is you can count. So that's the second search button on the page.
Oh, hey, that's cool.
Yeah.
What about looking at methods for using more visual programming-like things to do that sort of thing, like saying what identifies this and having the user click on the search button and then getting it.
Yeah. So certainly, it seems weird that we're not using the mouse here at all, right? It's certainly desirable to be able to record something, right? To allow the user to just enter this kind of interact with this thing themselves, whatever, and click on that search button, and that's the one that I mean, right? And in fact, we do have a recorder built into Chickenfoot, probably not on right now, but that would be able to record Chickenfoot commands that are associated with what you actually did, right? But I believe that we still need a textual representation for what you did. And I believe that representation needs to be understandable and editable by the user. So even if pointing and clicking is a great way to initially author the script, I think we need to think real hard also about how to display the script once it's been authored. Yep.
It seems like there's an obvious application for accessibility here. If you could get voice commands or something to scroll the page. Do things like scrolling text or changing font sizes, or because if you could do those kinds of things where you can manipulate what you're seeing as well as actually clicking on links and all that, then you've got a wonderful accessibility system here for using web browsers.
Yeah, I agree. And integrating with speech is like the next thing on our list of things to do. And in fact, one of the nice things about doing it in Firefox is that the whole browser is a DOM. So these techniques that we're using on the web page almost translate directly to interacting with the rest of the UI of the browser, the Chrome of the browser as well. So yeah, you could directly have accessibility to some of those features that you mentioned. Let me forestall more questions so that we can get on to the rest of the talk. So I argue that this is a natural way to do it. In fact, it might be the next step from pointing and clicking. If you think about natural as being how easy something is to learn, and you compare it to how human beings actually develop, pointing and clicking is sort of the capability of a 9-month-old, right? My 9-month-old was able to point at things that he wanted, right? And I understood what he meant. Now he's 2, and he speaks in keyword commands, right? He does not speak in fully formed grammatical sentences. He's pretty good at uttering words, but they're not really connected well together. And so it's hard for me to understand him sometimes, but I can figure it out because I have a lot of context. And likewise, I think our users are at the same level when it comes to talking to computers in a formal language, right? And we need to get our computers to become smart enough to understand. And I also mentioned that there might be some benefits for expert users as well, because they can be much more concise than they would have to be in a formal language. How does this actually work? I'm going to blaze through this part. Where before we had a representation of the web page, now we have a function database that represents all the commands that are available to the system. So for instance, we have a command for click that expects an object of a parameter of type button. And then we have another function that is able to find buttons on the web page, and it expects as its input keywords that are found on the web page. And associated with each of these functions is a set of keywords, which are basically synonyms for its operation. So click might have press and push associated with it. And these keyword types are mined from the page itself. So we just pull all the labels off the page to get that. So we process one of these keyword commands simply by trying to line up the keywords that we find in the command with functions in our database and construct a type-correct representation of a command that uses as many of the keywords found in the command as possible. And then we generate a bit of code, like a Chickenfoot code, out of that. Okay, so that's what we want to say about breaking down the complexity barriers for end users. The last part of the talk, I'm going to hand over to Michael, and he's going to talk about how web hackers, like developers at Google, might use Chickenfoot in their daily work.
So let's go back to Firefox. There we go. Okay. So obviously Chickenfoot, originally designed as a research project targeted at end user programmers, but most of you here are real programmers, which is great. And so I actually work on Google Calendar, and I've been using Chickenfoot since I got here to do various things. And if you're new to Chickenfoot, it may not be inherently obvious, like the power of having this sidebar, what this power gives you in the sidebar. So I'm going to go through some different types of things that I've been able to use this for, and hopefully you'll find it useful as well. So the first thing is that when it comes to the web, JavaScript is basically the hacking language, right? If you're at Linux, if you're trying to do little tasks on Linux, you're probably using Bash or Perl or Python or one of those languages. Maybe just write like a simple patch script, get something done, you throw away the code and you move on. On the web, that language is JavaScript. And the important thing about putting this sidebar in Firefox is that there's information in rendered web pages that's not available to other web pages, as if you just got the page from wget and had the plain HTML. There's extra information that we can use in the rendered web page to do tasks that we wouldn't otherwise normally be able to do. So the first example is this little script that I've written to replace, or basically to get a bunch of pictures in a web page, or to extract the pictures. So normally, if you ever hit a page like this, right, where there's a list of files and a bunch of them are images, and if you wanted to see what all the images in the page were, right, normally if you do this in Perl, you'd have to like wget all the files, you have to find a place to put them. But that's kind of silly because the browser's already good at displaying images. So here on the left, I have a little script in Chickenfoot. It's just a little for loop that basically says, for every link in the page, take the link and replace it with an image tag that points to the same place that the link pointed to. So when I run this script, it'll go through and actually just replace all the links with the images. And this is a lot easier, it's much easier to browse images this way. And also if you wanted to, going back to the example at the beginning, if you wanted to see which ones are transparent, right, you can just run this little script and now you see this one doesn't have a transparent background and most of the other ones do. So that's a first example of something that's just easily solved in Chickenfoot that otherwise would be pretty tedious. The next example is just inspecting objects in JavaScript. So a lot of times people have to make special debug divs in their web apps to try to look at things. So for example, in Google Calendar, if I'm looking at this page and I want to see how it looks on 800 by 600, we want to make sure that we can support users as that size. We know that there's some sort of resize command in window that I could use that would be handy for doing this sort of thing. So we have a command in Chickenfoot called list, which just lists all the properties and values of the object. All right, and so in Google Calendar, that's a pretty big list. And I know that it has to do with resizing. So it actually, list also takes an optional second argument, which is a regular expression that matches against the properties. Now I can find anything that has to do with size in window. So it looks like there's actually a resize to and a resize by. So now I can remember that it's resize to, and I run that in Chickenfoot. And if I close the sidebar, I see that we can still fit 4 weeks worth of data in Calendar, so our 800 by 600 users are going to be all right. So I sleep better at night. And so the next example is saving the HTML of a web page. So you might think this is kind of silly to actually have to write a script to do this, but let me show you what happens. So if you went to Google Calendar and you use the built-in save page as, all right, we'll save this to C drive, calendar.html. And so if you take a look at what you get, I actually get a bunch of duplicate HTML and some crashed junk, because the web page, actually, if you looked at the source of the web page, there's almost no HTML there whatsoever, and a lot of it's actually dynamically generated by our JavaScript. So I ended up writing a script that will, if you go to Google Calendar and run it, spits the page out and extracts the script tags and things like that would screw it up. And now you have a plain HTML version of the page that you were just looking at. And then for any of you who've ever been trying to tweak the HTML of a page or anything like that, this is much easier to just be able to save this out to a text file or HTML file, start editing it in Emacs, refreshing, and then go back to your code that was generating that HTML. So again, this is something where the information of about the rendered page, this is only available in the browser, and this is something that you couldn't do from regular command line scripting. The last thing that I want to talk about is making web prototypes in Chickenfoot. So one thing that we've recently added is the ability to take a script and package it up as a standalone Firefox extension. So right now, for example, if you used Calendar and you started trying to use these links in the upper left, and you clicked on Gmail and you get a new Gmail eventually, and then you clicked on Calendar, you get a new Calendar eventually, and instead of navigating back and forth between the applications, it was just a little unnecessary, to say the least. So we have a script that I wrote called gcal quicktab. So if I load this script and I run it on Calendar, it replaces this link so that it goes to Gmail, and I run it on Gmail, and replaces the Calendar link, and now you can navigate back and forth between the two. So this is pretty nice. This is a prototype I actually wrote the night Calendar launched. But now to package it up into a standalone extension, you can click on this button, and it grabs all the information about the script, which I added here, and it extracts it, and then it asks for an identifier, which I can generate a new one from Chickenfoot, and then save this extension out in its own file. And if you notice, really subtly, one of the things that this did is that it actually wrote all of the metadata back in. So actually, in this case, it added this ID. And for Firefox extensions, this is actually pretty important, because if you wanted to make a new version of your script, it's important that it has the same ID, so that when you send it to somebody, it replaces the old one instead of installing it on top of it. So by storing all this metadata into the script itself, so that the next time you go to this box, now all the things are populated the way that you'd expect. So this makes it a lot easier to create and then maintain Firefox extensions. So that's my tour of different ways that you can use Chickenfoot. So here's a number of resources where you can download Chickenfoot. There's two mailing lists. One is the internal list that I made here at Google if you want to discuss internal projects or things like that. The other one is the MIT mailing list, which all the Chickenfoot developers are on if you want to contact them. And the last one is another URL. There's about installing Chickenfoot on Linux at Google. There's a little quirk, and so I've described that there. So that is all the material that we have, and we'd now like to open it up to questions. Yeah?
Is it possible to package a bunch of scripts up and run them, sort of batch mode or something against the browser?
So
do something like unit tests.
Could you repeat the questions for the remote sites?
Sure. So the question is, can you bundle up a bunch of scripts and run them in batch mode?
Right. Just to do unit testing.
Right. So the answer is yes. So as I kind of glossed over, there's an include command in Chickenfoot. So you could write your scripts in separate file, or just have one script that's your testing framework, base script, and then include that in your unit tests, and then just schedule that to run. That'll bring everything in. Yeah.
The point earlier about actually recording the user maneuvers by using a mouse and keyboard, etc., and then generating a Chickenfoot script on the left side.
Yeah.
I think that would be really useful for developers or users that just want to write a script but don't know where to start. You could just record their session and then print out the script. They could just modify it for whatever they want to do.
Yeah, sure. So let me bring that up. So the comment was about the script recorder that we have in Chickenfoot. So if I turn that on, let's see. So if I go here and I click, or I type in calendar, it gets that I entered calendar. Click advanced image search, calendar here, small GIF like that. So it is mostly working, but we're still getting the bugs out of that, so which is why we haven't been promoting it as heavily. But you're right, that would help a lot of people. Yeah, in the back.
I had a question about tabs in Firefox. Considering that it's a Firefox extension, do you allow Chickenfoot to programmatically control another tab?
Yes. So from Chickenfoot, you can control other tabs. You can actually also open hidden windows, which is something that we didn't show. If you don't actually want to pop up the page that you're automating, you can actually automate it in the background and screen scrape it and get the data that you want from it.
And can you open new tabs based on stuff that you're clicking?
We have an open tab command, so if you want to, yeah, sure. So if it's pretty straightforward, just open tab and google.com, and you can choose true if you want to bring it into focus, and so I'll just open it up.
All right, thanks.
That type of thing. So cool. All right. Any other questions? Yeah.
So I noticed you have file access.
Yes.
Are there any other super fancy things like that?
So file access is one of the ones that we've wrapped. Wrapped the Chickenfoot API around. You actually have access to. All Firefox exposes a number of APIs on its own called or XP-COM objects. It's a cross-platform COM object, and you can get all of those from Chickenfoot. So there is a lot there, just not as much as wrapped, like with Chickenfoot specific APIs.
So I know there's this other project called PiggyBank at MIT. So it seems sort of symmetrical here. So you guys are providing this interface where users can easily insert commands to the web browser, and PiggyBank sort of sucks the content from the browser. Is there any sort of cooperation or joint effort there to produce something more seamless?
Yes. Yeah, there absolutely is. So the question was, what's the relationship between this Chickenfoot thing and PiggyBank, which is another MIT project, which is actually about sucking data out of pages into your own private piggy bank where you can work with it. Yeah, we are starting to work more closely with that group. One of the things that they do really well is screen scraping, and we don't have as much good screen scraping in here. So you've seen all of our keyword commands, or keyword patterns rather, are about poking at web pages. They aren't about pulling things from web pages. So the PiggyBank guy, his name is David Hoon, has written some kind of wonderful kind of screen scraping interfaces for you to describe, give examples of how you want to pull data out of web pages, and it will generate the XPaths for you, for example. So we're looking at incorporating some of his stuff into Chickenfoot so that you can get those XPaths and use them into your own scripts. We're also looking at ways to extend the keyword pattern idea to getting data out as well, so that if you have a pretty well formatted page, for example, that's a table, and it's got columns that are labeled like name, address, phone number, or something like that, we think you can create a keyword pattern representing the address column and pull that out. And if you simply said that, you would be able to avoid a lot of the complexity of the XPath. So we're looking at both of those directions. And back.
Can you do a textual replace on the JavaScript that's already loaded in the page? Repeat the question. The
question was, can you do a textual replace on the JavaScript that's already loaded in the page? And I actually don't know. We can certainly do a textual replace on the DOM. We could, so insofar as the text nodes, insofar as JavaScript scripts are text nodes inside script elements, we can replace them. But whether we can get Firefox to reinterpret them, I don't know. Also, we run after the page loads, because we want to make sure that it's completed loading before we operate on it. Whereas I think what you're describing, you'd want to actually fire before the page loads. Opera is capable of doing that, for example, but we currently don't have any way to do that in Chickenfoot. But that is an interesting idea. Yeah.
Can you extract elements of style, such as a font on the button, for example? Is there an easy way to do that?
Can you change them, or can you?
No, extract what's the name of the font on the button.
Oh yeah, sure. Yeah, that's. Do you know the code for that? So we can say something like find feeling lucky button. And ask for its style. And what is it called? Font size or font name? Font family? Why not? Maybe we'll use list.
If it's defined actually directly on the element, it would come out there. There's actually a get computed style method, which I don't remember the arguments offhand, but you could invoke that and see what style has cascaded down to that element if it's not defined on it directly.
Yeah, so it's not actually directly defined on the button, like Michael said. But so we haven't wrapped everything that you're able to do in JavaScript in an easy-to-use thing. But because we're building on top of JavaScript, there's all kinds of interfaces that are built into Firefox and built into client-side JavaScript that you can take advantage of if you know how to do them inside the browser.
So the basic, like, I'm feeling lucky of coding stuff where you're, kind of coding haphazardly. Like you mentioned shell scripts and how you have to be really particular. Like I'd love this for shell scripts personally because I'm good at JavaScript, but I'm terrible at Bash. Has there been any attempt to maybe insert this into other environments? Maybe if they implement a DOM, it could be done or something like that?
Well, so I see no reason why we couldn't do it in Bash. We're actually starting to look at doing it in Java, actually, so that if you're sitting in Eclipse typing Java code, you type a couple of keywords and maybe hit a special command key or something, and it generates some calls in the Java API for you that are relevant to your current context and those keywords that you type. So yeah, this idea definitely is not restricted to the web. I think it works really well on the web because we have a relatively small domain with a small set of things you can do in your current context, right, on this current page. So the ambiguity is low. Once you move into Java, for example, which has thousands of classes, or into Bash, which has thousands of commands scattered around your hard drive, the ambiguity grows. And so we're looking at that problem, both in terms of how to make the parsing fast, which is a big problem, and also in terms of how to keep the ambiguity under control and resolve it. Yep.
So, I mean, one of the things you said at the start was about how easy this is to do in web pages versus just any old plain application. I was wondering if you've looked at all being able to do this visually, just on anything you can see in your desktop, just with OCR, and be able to describe that looks like a button.
Yeah, we haven't looked at using OCR for it yet, although that's an interesting idea. I mean, another way you can get at this stuff, and this ties into the accessibility question earlier, is there are accessibility APIs on desktop applications that will be able to give you these kinds of labels, and may even be able to let you trigger them so that you can actually click on that menu item and trigger that command. Yeah, that's very interesting. So another little prototype we did, which I haven't showed you, is we did this in Microsoft Word. Although we didn't look at its user interface. In retrospect, we should have looked at its user interface because it would have worked better. What we did instead was we mined the Word API, the Word Basic API, in order to discover all the commands that we might generate. Yeah, so this is definitely a direction that would be cool, right? I mean, why should you stop at the browser? Just do anything you can.
Can you talk about security issues with downloading other people's Chickenfoot scripts?
Yeah, security, let's see, we have a page about that. Because security was important for... Grease Monkey had a big problem with security last year. It turned out that one of their API calls, GM XML HTTP request, would allow a malicious website to pretty much make an HTTP request anywhere. And in fact, to inspect your entire hard drive and things like that. So you have to think carefully when you're writing these kinds of things. And in fact, when you're just an extension developer for Firefox, you have to think carefully about whether you're opening security holes that malicious software could exploit. We have actually opened some holes intentionally, but we've tried to be a little controlled about how we open them. So we didn't show you this example, but one of our Chickenfoot scripts modifies a webmail system to inject faces of the people that you're composing a mail to. And those faces are stored as image files on your own hard drive. So you've got this remote page that's coming from the webmail system and local URLs to these files, and you want to inject the local URLs, the local images, into the web page. Normally, Firefox doesn't allow that because it doesn't want remote pages to just be able to create references to your local drive. So we created our own protocol, which we call Chicken Bypass, that allows us a controlled way for Chickenfoot scripts to inject references to the local page. And it's controlled because each of these URLs has to be basically signed. There's a hash in here that's a hash of the local URL along with a random nonce that's generated at runtime every time Firefox runs, so that a malicious site can't simply copy one of these URLs and put it in their web page and be able to inspect your hard drive that way. And these are only generated by Chickenfoot scripts. Another aspect of the security problem is, can users be fooled into installing something that they shouldn't, right? And yes, they can. But we hope that by making the scripts actually readable by ordinary people, that problem will be reduced. And if we can make the behavior of the script more transparent, the Grease Monkey script I showed you at the beginning is not at all transparent. It could be doing lots of stuff that you have no idea. Then maybe we can make that a little better. That address your question, Aaron? How much time do you have?
How did you come up with the name Chickenfoot?
This long to ask that question. Actually, I started on another project, another Firefox extension called Google Dominoes, and it was manipulating the Google DOM that things do, right? So I was going to have all these domino themed extensions. Chickenfoot is actually a type of domino that you can play, apparently. And I also thought it would be great because I figured we could get to the top of the search results list like pretty quickly with a name like Chickenfoot, but there's some domino site that's still ahead of us sometimes.
You mentioned that one of the driving forces behind this was to get end users of the web to write scripts. I assume you've run user studies on this. Have you seen varying levels of learnability based on, I don't know any programming and versus, I've taken a couple classes versus I'm a hacker, and like what they can do with the system?
Yeah, we have run some user studies. They haven't really been sort of end-to-end user studies in the sense that we've sat them down with tasks to actually create scripts for. We run narrow user studies looking at things like, can they generate keyword patterns to describe these features, and can they use keyword commands, for example. One interesting thing relevant to your particular question, which was about have we seen differences between real non-programmers and expert programmers in their approaches to this system. The answer is we have not really seen those kinds of differences. That they seem to approach keyword commands, for example, at basically the same level and trying the same kinds of things. It's probably all I can say about that because I don't. I'd have to go back and look more closely at the data to see some of those differences. But that's a good question. Yep.
Just wondering how long you think it'll be before we have keyword commands in Chickenfoot?
Oh, only a couple of months. There's a student working on it as we speak.
What was the question?
No, the question was how long will it be before keyword commands are integrated into Chickenfoot?
Oh.
Any more questions? Okay, one more.
Is Chickenfoot a standard Firefox extension that I can download and install?
It is not on addons.mozilla.org yet, if that's your question. Chickenfoot is not. So you asked whether Chickenfoot was a standard extension. It's standard in the sense that you can download it and install it, and it'll run in Firefox 1.5. So that's certainly true. It's not yet hosted on addons.mozilla.org. Okay, thank you very much.